Let us learn two more terms. Principal focus of the convex lens. So here we have shown a biconvex lens. MN is our biconvex lens, and we have this as our principal axis, and this is the optical center. When several rays of light parallel to the principal axis are incident on a convex lens, they converge at a point on the principal axis. It is the principal focus of the convex lens. The lens can converge light rays incident on it, and hence it is called converging lens. Every lens has two principal foci, f1 and f2. Now let us understand the principal focus of a convex lens with the help of this diagram. So as I said, MN is our biconvex lens. It's a thin lens, and we have shown the principal axis. The imaginary line passing through the centers of the curvature is the principal axis. Now here we have shown lines parallel to the principal axis. So we have, this is 1, 2nd, 3rd, and this is 4th. So 4 rays we have shown that are parallel to the principal axis. So this is the principal axis and all the rays are parallel to it. Now after falling onto the lens, or we can say after refraction, you find that all the rays are converging and they are meeting at one point, and that point is on the principal axis, and this point is called as the principal focus of convex lens. So this is the focus. We have labeled it as F2. So when several rays of light parallel to the principal axis are incident on the convex lens, they converge at a point on the principal axis. So these are the parallel lines, and these lines or incident rays are parallel to the principal axis, and after refraction they are all converging at a point on the principal axis, and this point is called as the principal focus of the convex lens. This lens can converge light rays incident on it, and hence it is called converging lens. So this point we have studied earlier also, and now we have shown this, that because a convex lens converges the light rays, it is called as a converging lens. And how many principal focus does a biconvex lens have? Two focuses, f1 and f2. So we have seen f2. Now if we would have considered the light rays that are incident from the right side, right now we have got light rays that are coming from the left side, but if light rays would have been incident from this side, that is right side, they would have converged at this point after refraction, and that point that is also on the principal axis, and it is called as the principal focus. So this is first focus and this is second focus. So that is why every lens has got two principal focuses, f1 and f2. But while drawing ray diagrams, we will always consider light rays are incident from the left side only. Another important thing, with respect to convex lenses, we will consider only the second focus. So second focus is to be considered while taking sign conventions. When we study, we will require this, and for convex lens we will always consider the second focus, that is f2. The distance between principal focus and optical center of the lens is called focal length. This is another important term, that is focal length. It is indicated by small f, and it is the distance between principal focus and the optical center of the lens. So this is the optical center and this is the focus. So the distance between the optical center and the focus, principal focus, is called as the focal length of the lens. So this is the focal length of convex lens. So we have studied two things, that is principal focus, and we have even studied the focal length. Next, let us learn the principal focus of a concave lens. So here we have a concave lens. both the sides it is curved inwards, and it is thin in the center, and towards the two ends it is broader. So it's a double concave lens or a biconcave lens. This is the principal axis, and we have shown two incident rays here. This is one with the blue lines, and this is second. When parallel rays of light pass through a concave lens, the refracted rays diverge so that they appear to come from a point called the principal focus. Rays of light that pass through the lens are spread out, that is, they diverge. Hence, we call a concave lens as a diverging lens. So this is a biconcave lens. The principal axis has been shown. The optical center is also shown. And we have shown two parallel rays here. This is one and this is second. And both these rays are parallel to the principal axis. Now, what is happening to these incident rays of light that are coming? Once they fall onto the lens, on refraction, they are diverging. So you can see that they are in the diverging direction. Similarly, this ray of light also comes and falls onto the lens, and after refraction it is diverging. Now if you extend these two rays backwards in straight line, you find that they both meet at a point on the principal axis, and it seems to us that the rays of light are coming from this point, isn't it? So it appears to us as if the rays of light are coming from this point, and this point on the principal axis where it appears as if the rays are diverging, and that point is referred to as the principal focus for a concave lens. So when parallel rays of light pass through a concave lens, the refracted rays diverge so that they appear to come from a point called the principal focus. So this is the first focus, F1. Similarly, if we consider the rays of light coming from the opposite direction, that is right side, again they will diverge, and when we extend them backward, it will appear to us as if they are diverging from a point on the principal axis, and that point will be the second focus, that is F2. So here also we have got two principal focuses, F1 and F2, but you have to remember that with respect to concave lenses, we will always consider the first focus, and we will use the sign conventions with the help of focus 1. Similarly, here also we can find out the focal length. It is the distance between the optical center and the principal focus. So here we will consider the first focus, and hence here it is the distance from the optical center till the focus, that is this. So that length is called as the focal length, and it is indicated as small f. So I hope you have understood all these terms, and now we are going to draw ray diagrams for these, and simultaneously you will also draw these diagrams in your notebooks. So we will start with the ray diagrams, and you will also draw in your notebooks.